Hola everyone. Today we're going to be doing the definition of a limit. And there's two ways to define a limit. There's the precise way, which is what you're going to find in almost every calculus book. And there's going to be a definition in our own words. So this video's lesson is going to be the definition of a limit. Defining it. So the objective, what are the two things you're going to learn today? You're going to define a limit using the precise definition. And number two, you're going to restate the definition of a limit using your own words. Now, let's go ahead and read the precise definition of a limit. Let f be a function defined on some open interval that contains the number c, except possibly at c itself. So it can be c, it can be c, or it cannot be c. That's what it's saying right there. Then the limit of f of x as x approaches c is the number L, and we write it as the limit of f of x as x approaches c is going to equal to L. Now, what does it mean by the precise definition? The precise definition is going to say if for every epsilon greater than 0, there is a delta greater than 0, such that for all x, where x minus c is between 0 and delta, then that's going to imply that f of x minus L, the absolute value, is going to be less than epsilon. So you're going to be looking at that, and this is where a lot of students get lost right here. What do they mean? Okay, so what I'm going to do is I'm going to actually take the visual here. So remember, we're going to go x is going to go with delta here, and the epsilon is going to go with L. All right? So I'm going to have a visual here, and this right here, this is my L. And right here, this is going to be an epsilon, and this is going to be an epsilon. So I'm going to find some epsilon. This is the part that we're going to find right here. But I'm going to say some degree. I'm going to be able to find, you have to remember that we're trying to find the limit here at C. We're trying to find the limit there at C. And what I want to do is I want to say, how close to C do I want to get? And this is the one that I want to say. I want to get to close to C, but by some error. So I can say delta is going to equal to 0.01, or I can say that delta is going to equal to 0.1, or you can say, you know what, delta is going to equal to 2. That's far away from my C. I don't know what C is. C could be 3, or C could be 7. We don't know what C is. But I want to pick so that we're gonna have some kind of margin of error right here. So right here, this is my C, and I want to know how far I'm gonna be. All right. So right here, if I go my margin, which is going to be my delta, that's going to give me my right bound. And if I subtract it from my C, I'm going to get my left bound. So this is the window that I want to find my C. Okay, so it's going to be the absolute value. So what I'm saying is, when I do the absolute value, I'm going to be adding it and subtracting it. Now, if I pick this error, that means that over here on this other side, there's going to be an epsilon. Now that epsilon is going to be greater than 0. So right here, if I add it, I'm going to go up, and if I subtract it, I'm going to go down. So this is the window that I'm going to have. So I'm going to have some picture here. Let me go ahead and draw some picture here. I'm going to go like this, and let me put here this, and do this. So Mr. Quintana, here is my C plus delta. So I'm going to go straight up like this, and it's going to go straight up like this, and that's going to go, and it's going to meet this one here. And then over here, I'm going to subtract it from C, and it's going to give me this little window here. This, and that's going to go like this. So what this is saying is, remember we chose delta. Whatever delta is, that means that there's going to be some epsilon that is also greater than 0, where I have a little window. All right. So Mr. Quintana, if I had chosen something smaller, that means that my window would have been smaller. So here's my window. So if I go straight up, and I go straight up, and then I'm going to come this way, and I'm going to come this way. What does that mean? That means that my epsilon now is a little bit smaller over here. So we're determining the delta, but then if we determine the delta, then there's going to be some epsilon out there that exists, where we're going to have a window where f of x is going to be inside that window. So here is L, and here is my f of x. So f of x is going to fall within that window. That's the precise definition. Now you say, man, that's complicated. Now you might want to see the different versions. We're going to be uploading other videos that you're going to be able to look at, and maybe somebody else might explain it a little bit different. But if you get it on the first time, wow, I'm going to say I'm really amazed. Okay. Now, what does it mean in other words? What does it mean to me? In other words, the limit of the function is really just the y coordinate that the function approaches, and not necessarily where it is defined as x approaches a certain value, as x approaches c. That's the definition in my own words. So when I ask for the limit, I'm actually asking for a y coordinate. So let me go ahead and give you a little example here. Let me go ahead and then sketch a what is it? XY axis. This is going to take forever. Okay, now if I have some function here, so let me undo that. Let's pretend I have some function here. Oops. And Mr. Quintana, here is 1, 2, 3. So this is 2. This is the one I want. And let's pretend I have 1, 2, 3, and I have this up here, and it goes like this. And let's pretend that I want the limit. Okay, so the limit as x approaches 2 of my function. Okay, now sometimes this function here, that function right here, is going to be either f of x, or it might be some algebraic function. Okay, but in this one we're doing graphical functions. So I'm going to find the limit as x approaches 2 of this function. So Mr. Quintana, basically here is my 2, and I'm looking where would my function be approaching. So, well, if I'm coming from the left, if I'm coming from this side over here, as I'm coming from the left, the graph, I'm on the graph is going to be approaching that hole, and that hole is located at 3. Now, what happens if I'm approaching 2? Remember, I'm approaching 2, so that means that I'm coming from the right. So that means I'm on the graph. Where's this graph approaching as I'm coming from the right? Well, my graph is approaching this hole also from the right. So that means that my limit is going to be 3. And that is the definition of a limit. What y coordinate is my function approaching as x approaches this certain value right there? Okay, so let me try now. Let's say Mr. Quintana, let me undo, that's a horrible line. Okay, so let me do another one, and let's pretend I want to do some function over here, and I'm going to do this function here. And I'm going to go like this, and I'm going to go like this, and let's pretend that there's a dot right here. So what is the limit of f of x as x approaches? Now I have to pick a x value here, and I'm going to pick this value right here. This is the value that I want, 4. What is the limit of f of x as x approaches 4? All right, so as I come from the left side, remember, here's my 4. 4 right here, as I like to draw an imaginary line here at 4 right here. As I come from the left side, as I'm coming on the graph, remember I'm traveling on the graph, as I'm coming from the left on my graph, what y coordinate am I approaching when I get to this imaginary line that I drew? Well, I'm approaching this hole, and this hole is located at 1. But then I also have to do it from the right side. As I come from the right side, what y coordinate am I approaching as I approach x equals 4? So this is x equals 4. And I'm also approaching that hole, and that hole is located at 1. And that is the definition of a limit. And most students, when they confuse this, they want to go back to algebra and they want to say that the answer is 2 because the dot is that 2. Now remember, the limit is not where f of x is necessarily defined. It's what the function is approaching. And that is the end of today's video.